Okay, this is going to be part 3 of my case for the continuum hypothesis. This is actually going to be the conclusion. I beg you, please don't jump to the conclusion without following the logic. You have to look at part 2, where I come up with the central thesis that I believe will affirm the continuum hypothesis, and that is that 0 times any cardinality above Aleph Nought, meaning Aleph 1, Aleph 2, Aleph 3, is undefinable and does not exist. I lay out a case for that that's philosophical, that deals with the fact that Aleph 1 transcends the 0-1 dichotomy, that it transcends, that all discrete counting is based on the 0-1 dichotomy, which I'm going to further clarify, by the way, because I know that's a little vague. So I'm going to clarify that here, and then I'm going to try to conclude with why I believe that CH is valid and why I believe that affirms CH. Please follow along with the logic, and then after this I'm going to do a postscript that's going to be a personal thing. It's going to be for me, okay? And that you can comment on these. Please don't comment on that one because it's my personal story. Okay, I apologize in part 2 for the fact that I made a very vague statement, which is all of the counting numbers are based on the 0-1 dichotomy. I'm going to further clarify that. I'm going to make a specific case for that right now. Okay, let's get back to 0 and 1. Okay, I'm asking a question. How many sets are in the null set one way? Well, by the definition of the null set defined actually, I say 0. There is no set in the null set. But looked at in a kind of nominalist sense, where I define the null set as a set by invoking it as a concept, it is now a set. I now say 1. Okay. Now with 0 and 1, I can generate 2 by asking how many members are there in that set, or looking at it another way, by the null set, comma, the singleton of the null set, I now have, well, how many members are in that set? I say 2, but I can only do that with the same logic that allowed me to invoke 1 the last time, by asking how many members of the set are in the set of the null set. I now, because if I can't address the null set, nominally speaking, as a set, then the entire house of cards collapses. Then I just have the null set, i.e. 0. So I have no 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on to Aleph Nought by way of the Axiom of Infinity. Okay, I don't have that because I've now disallowed that as even being possible. I just have 0. So in a sense, the 0-1 dichotomy, the 0-2 dichotomy, meaning I either have the set 1, in which case I would have the set 1, or I don't, in which case I would have the nullity of the set 1, or 0 times 1, which would be 0. 0 times 2 is equal to 0 with that same logic. In other words, the nullity of the set 2 would be 0 again, based, if you really want to think about it abstractly, you can say that the nullity of any set generated by the Axiom of Infinity is just the same as disallowing you from considering the null set as a set, as a definable set, and thus the house of cards collapsing to where you just have no set, or 0. So 0 times 1 is equal to 0. 0 times 2 is equal to 0. 0 times 3 is equal to 0. 0 times 4 is equal to 0. 0 times Aleph Nought is equal to 0. Okay. What about 0 times Aleph 1? Well, if you accept the idea that 0 times... Well, I can't prove that 0 times Aleph 1 is undefined, or that it's not equal to 0. That's an axiomatic assumption. But I believe you can argue its consistency with the Axiom of Infinity by stating that Aleph 1 transcends the whole level of countability, so that it transcends anything you can generate using the null set through the Axiom of Infinity. Aleph 1 is automatically above that. So philosophically, I say 0 times Aleph 1 is undefined because Aleph 1 is not part of a discrete 0-1 biconditional, but more, even if you don't accept that, you can't adamantly prove that 0 times Aleph 1 is equal to 0. You can't say one way or the other. Okay, that's heavy-duty abstract logic, and you may accept it and you may not. But let's say, and if you don't accept it, shut this off, because I don't want you to get an F on your thesis, okay? Or your professor to call you nuts. But let's say you do accept it, and you have 0 times Aleph Nought is equal to 0. Let's say you just accept it. Let's see where it leads. Okay, 0 times any Aleph Nought is equal to 0. Okay, now remember, in part we know this because multiplication is distributive, and any kind of adding, if you have parentheses and you're adding anything together, you would have 0 times Aleph Nought plus 0 times Aleph Nought plus 0 times Aleph Nought, which is just 0 plus 0 plus 0 is equal to 0. So even if it weren't true that this were the same as Aleph Nought, any time you have 0 times anything plus anything plus anything plus anything, that's just going to be 0. Now that's true if you have 0 times any finite number of things multiplied together, like a times a times a times a. That's just the same as if multiplication were distributive with 0, because you'll get 0. But what if I have 0 times Aleph Nought times Aleph Nought times Aleph Nought times Aleph Nought forever? Now I have a whole other question, because if I have an infinite set of one thing that and an infinite set of another thing that cancels it out, do I have everything canceled out? Let's say I had an infinite number of protons matched to an infinite number of electrons. Would I have a neutral charge? Okay, you would have to say no. Just understanding the nature of infinity, I cannot define 0 times Aleph Nought to the power of Aleph Nought through a kind of primitive, through naive set theory, right? Okay, let's say I have Aleph Nought times Aleph Nought times Aleph Nought times Aleph Nought forever times 0 times 0 times 0 times 0 forever, and note this is kind of the funny way I have it, so that my zeros and Aleph Noughts cancel every step of the way. You would think that'd be 0, but let's say I have a Hilbert's Hotel situation where I move all the Aleph Noughts over here and have a whole bunch of new Aleph Noughts there. It still reduces then to 0 times Aleph Nought to the power of Aleph Nought, which, if I assume, is undefined, and it appears from a kind of naive set theory logic that it is, just by naive set theory logic. There might be some other logic that would affirm that 0 times Aleph Nought to the power of Aleph Nought is equal to 0. But if I assume that it's undefined, that's consistent with my axiom in part 2. Okay, so this result is consistent with my axiom in part 2. Let's say I invoke an Aleph 1 that is between Aleph Nought and C, okay, or that is between Aleph Nought and the power set of Aleph Nought. Well, I have a problem, because if I were to map that out as Aleph Nought times Aleph Nought times Aleph Nought some a times, such that Aleph Nought to the power of a is equal to Aleph 1, and that'd be some weird a that would be neither finite nor infinite. I don't know what it would be. I don't know that we could do that, but in order for there to be an Aleph 1, it would make sense that we would have to be able to do it. Aleph Nought to the power of some a, which is neither finite nor Aleph Nought, but somewhere in between, would get you Aleph 1. So if we invoke that a as existing, then I have Aleph Nought times Aleph Nought times Aleph Nought some number of times multiplied together, and that number of times would be less than infinity. Well, look at my zeros. I have an infinite number of zeros that multiplied together still get me 0. So my 0 times Aleph 1 would be 0, contradicting my initial assumption. So if you accept my initial assumption for the sake of argument, and you accept that that axiom is valid and consistent with the axiom of infinity and consistent with set theory, I haven't explored the axiom of choice yet. So, there might be a problem there. I welcome insights on that. But if you accept that it's consistent with set theory, then you cannot have any Aleph 1 between Aleph Nought and C. It's not possible. Okay, so my assumption that 0 times Aleph 1 is undefinable and cannot be thought of as being 0 would affirm the continuum hypothesis. So if one, then the other. That's my argument. I'm through. So the next one is going to be a postscript. I hope you'll tune in and enjoy it. I thank you very much. I welcome all criticism, provided that it's not personal. Thank you.